Then we move to problem number 2. It says the angles of reflection of 200, 110 and 111 planes are 14.9, 9.14 or 9 degree, 14 degree 9 minutes, 9 degree 14 minutes and 15 degree 3 minutes. What will be the ratio of interplanar distances? Okay, this is very simple problem. We need to calculate alpha, lambda. Okay, so lambda and d, okay, so these are all given here. Okay, so you need to calculate d we need to calculate. Okay, so we know, okay, so for 200 plane, lambda will be d200 sine theta 1, right? Okay, and for 110 plane, lambda is d110 sine theta 2, and for 111 plane, lambda is d111 sine theta 3. So we need to calculate d200, d110 and d11. Okay, ratio of the interplanar distance. So d is the interplanar distance, we know. Okay, so now we need to calculate d200 is to d110 is to d111. It will be your lambda by sine theta 1 is to lambda by sine theta 2 is to lambda by sine theta 3, right? So we can write 1 by sine theta 1 is to 1 by sine theta 2 is to 1 by sine theta 3. Now we put the value of theta 1, theta 2 and theta 3. Okay, so we write sine 1 by theta sine 14 degree 9 minutes is to 1 by sine 9 degree 14 minutes is to 1 by sine 15 degree 3 minutes. So if we calculate this one, this will be your 0.244 is to 1 by 0.160, 1 by 0.244 is to 1 by 0.160 is to 1 by 0.259. So we get 4.098 is to 6.250 is to 3.861. So this is the answer. Next we discuss problem number 3. It says for a crystal lattice the length of the unit cell is 6.52 angstroms. What will be the angle of reflection from the 110 plane if the wavelength of the incident light is 1.65 angstrom? So here lambda is given. Okay, so for a second order reflection maximum, so for a second order reflection maximum, maxima 2 alpha 2 lambda equals to 2d sin theta. So NaCl, okay, NaCl is a face centered lattice. Okay, so write, so d, okay, so d110 is a by root 2. Okay, so we write 6.52 by root over 2 angstrom. So we get 4.61 angstrom. This is the value of d110, right? Now we can calculate sin theta. We need to calculate theta, right? Because the angle of reflection theta. So we need to calculate sin theta. Okay. So since sin theta equals to, now we discuss sin theta, since Sin theta is from here, right? Sin theta is lambda by d. Okay, the value of lambda is given 1.65 and value of d is 4.61. So if we calculate this one, we get 0.358. So this is the value of sin theta. So therefore theta is sin inverse 0.358. So you get 20.977 degree. Therefore the angle of reflection is is 20.977 degree. Move to problem number 4. It says the angle of reflection for a first order X-ray beam from 110 plane of NaCl crystal is 7.8 degree. Calculate the wavelength of X-ray. What will be the angle of reflection if lambda of the X-ray beam is 1.65 angstrom? The density is given. Density of NaCl is 2.165 gram per cc. Okay. So now we start with the molecular weight or molar mass of NaCl is 23 plus 35.5. So gives 85.5, no, 55.5, 58.5 grams per mole. Okay. So this is given. So volume, so what will be the volume? Because the rho is given. So volume or molar volume, so molar volume of HCl, NaCl, molar volume of NaCl is, so mass is given, density is given, so from there we can calculate. So 58.5 by mass by density, so 2.165 cc. So we can calculate this one as 27.02 centimeter cube. So this is the molar volume of NaCl. Now NaCl has FCC lattice. We already discussed NaCl has FCC lattice. So number of atoms per unit cell is 4. This also we discussed. Okay. So number of atoms per unit cell is 4. Now Avogadro number, or a 6.022 times 10 to the 23 molecules occupy 27 point, this is molar volume, right? 27.02 centimeter cube, right? So how many atoms per unit cell? 4 atoms. Therefore molecules or atoms, right? Therefore 4 atoms will occupy 27.02 by Avogadro numbers, 6.022 times 10 to the 20, 10 raised to the 23 times 4 centimeter cube. So if we calculate this one, we get 1.795 times 10 to the minus 22 centimeter cube. This is the volume occupied by 4 atoms. Okay. Okay, or 4 molecules here. Okay, 4 molecules. NaCl we are considering, so 4 molecules you can consider. Okay, now A cube will be 1.795 times 10 to the minus 22 cc or centimeter cube. Okay, so A will be 5.64 times 10 to the minus 8 centimeter or 5.64 angstrom, right? Okay. So for a first order reflection of 110 plane, okay, so lambda will be 2d So sin theta, so lambda will be 2 times a by root 2, okay. Then sin theta. Now how we are getting a by root 2? So as d110 means a by root over h square plus k square plus l square, right? We already discussed. And so we get a by root over 1 square plus 1 square plus 0 square. So we get a by root 2. That's how what we get a by root 2 here. Okay, so lambda we get this value. So it's given 7.8. Theta is 7.8. Okay, here theta is 7.8 degree already given. So 2 times a by root 2 sine 7.8 degree. Now value of a we know. Okay, if we put the value of a here, okay, so we get lambda is 2 times 5.64 by root 2 and then sine 7.8 degree. So if we do it, we get 1.08 angstrom. Okay, the value of lambda we got. Okay, now if another point is, if lambda is 1.665, what will be the theta, right? Okay, now if lambda is 1.65 angstrom, then 1.65 angstrom, lambda is root over 2 a sin theta or 2d sin theta. First we can write 2d sin theta. So 2d sin theta. So 2 times a by root 2 sin theta. Okay, and now we get square root 2 a square root 2 sin theta. Now value of a is we already got 5.64. So we get 5.64 times root 2 sin theta. Okay, this is your 1.65. So we get sin theta is 1.65 by 5.64 times root 2. So from there we can calculate theta. Theta is 11.89 degree. Okay, so if lambda of the X-ray beam is 1.65, the angle of reflection will be 11.89. This is the angle of reflection. Next we move to problem number 5. It says, what will be density of tungsten crystal if the edge length of the unit cell is 3.16 angstrom? Tungstens form body center cubic lattice and the atomic weight is 183.8 grams per mole. So for a BCC crystal or body center cubic crystal, so for body centered cubic crystal, cubic or a BCC crystal, number of atoms per unit cell is 2, right? We already discussed. And here what is given? Edge length is given. Unit cell is 3.16 angstrom. Here A is here the edge length of the unit cell. A is 3.16 angstrom, right? And atomic weight of angstrom, tungsten, atomic weight of tungsten W is 183.8 grams per mole. Therefore, the density, if we say rho is Z times M, we already discussed in the class, times Y divided by Na times A cube, right? Now Z is 2 here, okay, and M this is molar mass or atomic mass here, so 183.8, and Avogadro number is 6.022 times 10 to the 10 raised to the 23, and value of A we know 3.16, so A to the cube means 3.16 raised to the 3, 0.16 raised to the 3. Now here okay, so we need to convert this one in so 183 is grams per mole. This is given, Avogadro number is 6.022 times 10 to the 23. So this is angstrom, so we can convert into centimeter. Okay, so if we convert it into centimeter, we get 3.16 times 10 to the minus 2 centimeter. So we will put it 3.16 times 10 to the minus 8 raised to the 3. So we get, this is grams per mole, this is per mole, so you get the unit gram per centimeter cube. So this is the unit of rho. Okay, so now we calculate all these values. So if we calculate this one, we get a rho is 19.34 grams per centimeter cube. Move to problem number 6. It says, what will be the Miller indices if the intercept of a plane is 316? What will be the distance between one plane in a BCC crystal if the volume of the unit cell is 3.6 times 10 to the minus 23 cc? Okay, here y is indices, here y is indices are 316. So the Miller indices is the reciprocal of y's indices, that we already discussed. Therefore Miller indices is 1 by 3, 1 by 1, 1 by 6. So if we multiply everything by 6, we get 6, no, 2 is to 2, comma 6, comma 1. Okay, so this is the Miller indices. The first part. Now volume of the unit cell is given. So volume of the unit cell, again the volume of the unit cell is 3.6 times 10 raised to the minus 23 centimeter cube. Okay, the length of, therefore the length of the unit cell okay, so therefore length of the unit cell, this is called A, so this is A cube, right? So A cube is 3.6 times 10 raised to the 23. So the length of the unit cell A is 3.6 times 10 raised to the minus 23 to the 1 by 3, right, raised to the 1 by 3, this is in centimeter. Okay, so if we calculate this one, we get 3.3 times 10 to the minus 8 centimeter. So we can get 3.3 angstrom. This is the length of the unit cell A. Now for D11 BCC, for D11, okay, or so D11 for BCC, for BCC. Okay, so it will be A by root over 1 square plus 1 square plus 1 square, right? So we get A by root 3. So it will be 3.3 by root 3. So we get 1.90 angstrom. Next we discuss problem 7. It says an element can exist in two forms, alpha and beta. The alpha forms makes an FCC arrangement with box length A equals to 3.12 angstrom, and beta forms makes BCC arrangement with the box length of 2.62 angstrom. What will be their ratio of their densities? Okay, so let the atomic weight of the element is m. We need to calculate density. Okay, so let the atomic weight of the element is m. Okay. Now density in alpha form, if we get rho alpha is m times z by Na times a raised to the 3, right. So m times, what is the value of z for alpha for FCC arrangement? This is 4, right, and Na, and box length is 3.12 raised to the 3, right. This is for alpha form, the density, and for beta form, again the density in beta form if we call this rho beta is again m is m times for beta form. These forms beta form is from BCC. For BCC this is 2, Z is 2 here, and this is Na, and the box length is 2.62, so 2.62 raised to the 3, right. So ratio of that density, therefore rho alpha by rho beta will be m times 4 by Na times 3.12 raised to the 3 by m times 2 by Na times 2.62 raised to the 3. So if we calculate this one, we get 2 times 3.12 by 2.62 by 3.12 raised to the 3, and if we calculate further this one, we get the value is 1.184. So we get 1.184. So this is the ratio of their densities. Move to problem number 8. It says, what will be the distance between 1, 3, 4 planes of an orthorhombic arrangement of an element A equals to 0.75 angstrom, B is 0.585 angstrom, and C is 1.25 angstrom. Okay. So for a crystal, one by d square HKL is h square by a square plus k square by b square plus L square by c square, right. So therefore is 134, so 1 by d square 134 will be 1 square by a is 0.75 square plus k is 3, so 3 square by b is 0.85 square, and c is L is 4 square by 4 square by 1.25 square. So we get 1 by d square 134 is 24.47. So we calculate this one, so we get d 134 will be 0.202 angstrom. Therefore the distance is 0.202 angstrom. Move to problem number 9. It says CSCl forms a cubic crystal where chloride ions occupy the corners and Cs plus occupy the center and vice versa. What is the distance between neighboring Cs plus and Cl minus ion? Calculate the radius ratio. Rho is given 4 gram per centimeter cube, and assume that two chloride ion can touch each other. Atomic weight of Cs plus is 132.91, and for chlorine or Cl minus is 35.5. So molecular weight of CSCl is, we can always calculate first. Okay, so molecular weight of CSCl is 132.91 plus 35.5. So we get 168.41 grams per mole. Okay, so the density of CaCl crystal is given, right? Crystal is 4 gram per centimeter cube, Okay, so we can calculate molar volume, right? So molar volume of CaCl will be 168.41 by 4 centimeter cube, right? So we get 42.10 centimeter cube. This is the molar volume of CaCl. Now number of atoms of CaCl or volume of unit cell of CaCl first. Okay, so volume of unit cell. So first we calculate volume of unit cell. Okay, it will be 42.10 by 6.022 times 10 to the 23 here. So if we calculate, we get roughly 7 times 10 to the minus 23 centimeter cube. Okay, so length of the unit cell, therefore length. So volume of unit cell is A to the 3, right? Okay, so the length of the unit cell, if we call A is 7 times 10 to the minus 23 raised to the 1 by 3. Okay, so if we calculate this one, we get 4.12 times 10 to the minus 8 centimeter, or we can write this one as 4.12 angstrom. Okay, therefore body diagonal, will be root 3a, so we get root 3 times 4.12 angstrom, so it will be 7.14 angstrom. Okay, so as it is BCC, that is, it says as it is BCC with CS plus at center and Cl minus at corners. So we can write 2R plus 2R minus equals to 7.14. So from there we can calculate R plus R minus will be half of this, so R plus R minus will be 7.14 by 2, so we get 3.57 angstrom. Now as Cl minus touch each other, as Cl minus ions touch each other along the unit cell length, we write 2R minus radius. Okay, 2R minus is 4.12 radius of Cl minus. Okay, so 4.12 angstrom. So we get R minus is 4.12 by 2, so we get 2.06 angstrom. This is R minus. So we can calculate now R plus. Okay, therefore from there we can calculate R plus. So R plus will be 3.57 minus R minus. So we get 3.57 minus 2.06. So we get 1.51 angstrom. So we got the value of R plus and R minus. So we have to take the ratio of them. Okay, therefore R plus is to R minus. First your R plus by R minus is R plus is 1.51 and R minus is 2.06. So if we calculate this one, we get 0.7. 0.73. So r plus by r minus will be 0.73. Okay, therefore the radius ratio is 0.73.